So, provided this 3069, I'm always going to draw to the side the basic relationships between all the sides in a 30-60-90. Okay? So every 30-60-90 triangle, the side opposite 30 is always going to be the smallest. The hypotenuse will always be twice as big as that. And then the other leg will always be radical 3 times as big as n. Okay? So I have that. Now what I'm going to do is talk about what shape we have right here in purple. Because when I have my right triangle here, I'm going to put it on top of this one and see what matches up, right? And there are no numerical values right now on this green triangle that are going to match up to these n, 2, and n radical 3 sides. So I need to put a distance over here somehow. And that distance gets created by knowing what this, because this is a right angle here, this is going to be a right angle, what kind of shape this is. Anybody know? Purple shape is, if you've got 3 right angles in a quadrilateral, it is a rectangle. Okay? Now, it might eventually be a square, but we don't know the lengths of those segments yet, so we can't make that argument. But we know it's a rectangle. And if it's a rectangle, what do you know about that side there compared to that side? They're the same. So I'm going to transfer that distance as 4 radical 3. All right, so now that we have that, we can now play this game where I take that and I put it on top there. And you see, hopefully, that the n radical 3 and the 4 radical 3, they're what's matching up, right? Now, I know you guys can't, obviously, this would be nice if everybody had this in their notebook and they could do that, right? So you're drawing pictures and that type of thing is going to be, I think, to be successful is a necessity. But we see it that and that match. So if I drew this triangle so that it was congruent to that one, and that means by CP/CTC, the n radical 3 side should equal the 4 radical 3 side. And I generate that little equation. If I tried to, and I was telling Landon this, and I know in my notes I gave you yesterday, that's why I tried to maybe not give you enough time to write all the written notes down in the PowerPoint. If you want to go to the PowerPoint and download it, you can and look at the written notes. But the way I wrote those is they give you rules for it. If they give you this segment and you're looking for this segment, you divide by 2. Or if they give you this segment and you're looking for this segment, you divide by radical 3. Or if they give you this segment and you're looking for this segment, you multiply by radical 3. I think those rules are so hard to keep track of that they're almost kind of pointless to learn, okay? If you can do this, draw these 2 pictures and then kind of use them as an overlay, okay, or transparency on top of one another, it automatically generates the equation that is really telling you, do I divide by radical 3, do I divide by 2, do I double it, do I, whatever, okay? So here, to solve for n, it tells me in this case I would be divided by radical 3. Does that make sense? And that gives me n. The radical 3 is all canceled, so it gives me n equals 4. Okay? And so if we go back to like the written rules, that says if they give you the side opposite 60 degrees, which is what we have for radical 3, and you want to find n, then the rule is to divide by radical 3. Okay? I just don't like remembering that. I think that's a tricky thing to do. So would you guys agree that that distance, that's n, that purple distance is n, because that's what it is over here in this triangle, right? So that's our 4. How do I go from 4 to A? Multiply it by 2, right? Because that's the relationship over here between those 2 things. The hypotenuse is double the smallest side. So I've got 4 as the smallest side, double it, I get 8. Okay. And this isn't, remember, I'm going to delete some stuff here real quick. But remember the original picture was this, right? So what is that 12 referring to? 12 is referring to that whole distance there. Does that make sense? But we just found 4 of it. So how big is that blue section? 8. And remember what kind of figure this was? The rectangle, right? So what's B got to be? B is 8 as well. Does that kind of make sense? Okay. Now, and I think it's important if you know, every education class I've ever taken that tells me how to teach says that students should be provided insight on what they're going to be doing in the future. Make connections with what we've done or what we're currently doing to what you've done in the past, and make connections to what you're going to be doing in the future. In the future, like I said, I'm going to try to find the area of this trapezoid. The area of a trapezoid follows this formula here. And you don't need to write this down, but I think knowing that this stuff is coming up again in the future might make you spend more time on this now. That's the formula for the area of a trapezoid. Okay? H is that distance right there. B1 would be the 12. Does that make sense? And those are things that were given in the original picture. But B2, which we found to be 8, was hidden from us in the original picture, right? And we had to go through this entire process to pull that B2 out, that 8, so that eventually in chapter 10 or 11 we can find the area of this thing. All right? My hope is that when you see this picture again in chapter 11, because we've seen special right triangles, we've done things like this so much, that all we've got to worry about is remembering that formula. Because finding H, B1, and B2 will be something that it'll be just instinctual. Okay? There was one, and this in the last class we started talking about, and I think this is important because it gives us an opportunity to talk about some number sense things. Let's do this question, and I'll give you the same instruction as, give you a couple minutes to work on it, talk to one another. This is the last question from the homework. All right, so this is one I hope you see that there are 2 triangles here, right? Okay, 2 triangles. I guess there's actually 3, but there's 2 right triangles that are important here. Does everybody see that green triangle? Okay, and then there is also, I'll do it in purple, that darker triangle, yes? Okay. Now the 30 degrees is that top angle in the green, and the 45 is obviously the top angle in that dark triangle. So but what they're saying here is that we've got a wall that has had some damage to it on a house, and the contractors are trying to brace this wall. Okay, so they take a 2x4 here, which they know is 16 meters long. Okay, so it's a pretty large 2x4. And tack it to this wall, tack it to the ground, and then they take another brace, and they do the same thing, tack it at the same spot, but a different spot on the wall, and that should support that wall. Okay. They want to know how long, based on knowing how long that purple one is, we can determine how big that red one is with these angles. Okay. So the first part of the question is to find out how long is that red brace. The second part of the question, they word it as how much further on the wall, or much higher on the wall, does the red brace touch than the purple one. So I want you to find essentially that blue distance. So those are the 2 things that I want to work on. just find right now, just find how long that red one is. Okay, so take a minute, work with one another, see what you can do. I think it's important to maybe draw separate triangles here. It would be helpful.
For long length of the 30, one of these 16 radical 2?
Well, let's go back to, so you got this to be 8 radical 2, right?
Yeah, because it would have to be a side.
So that's your, yes, so you double that to get, yep. Yep.
And then for the shorter length, 8 radical 6. The shorter leg times radical 3. Since that's a radical.
Yes, so that means this whole distance right here would be 8 radical 6. To find that distance, then we're going to subtract that one and that one. So we're going to talk about that here in a minute. So let's just let's come back to, is there confusion here? Is this okay? So ask yourself, when there's confusion, how are you addressing? Did you pull triangles apart? Because I think the best way of doing questions like this, especially when they've got overlapping triangles or multiple triangles, it's really kind of maybe 2 or 3 problems inside one. So I try to tackle it one triangle at a time. Okay? So I highlighted the one over there that's green. That was yellow, and I went over it with blue, so it turned green. But we got the 45-45 yellow triangle, right? Okay. Do you know a dimension out of that triangle? Do you know a side length of it? So where I could take this image and lay it on top, what's the 16 laying on top of? N radical 2. So right there is my equation. So 16 and N radical 2 are equal. Alright? I'm going to divide by radical 2. So it gives me N is equal to 16 over root 2. Do I like that denominator? So I'm going to multiply by radical 2 over radical 2, right? So it gives you 16 radical 2. I'll clean this up in a minute. 16 radical 2 over 2. And that gives you 8 radical 2. Is that okay? Questions on that? Okay, so N, in this case, becomes 8 radical 2. And if I look at my 45-45-90 triangle, N is that side. So if I put it on top of this yellow triangle, that is N. That's 8 radical 2. N is also that side, so that's 8 radical 2. Okay? Questions on that? Is that okay? All right. So now, how do I use that information to get into the blue triangle? If I look at that right there, does that 8 radical 2 become a distance of that blue triangle? That makes sense to everybody? The 8 radical 2, so let me just highlight this in red, that distance right there that we just found is that distance, which is the same as that one, right? So now in the blue one, I know a distance in that blue triangle. Does that make sense on how to transfer those values? All right, now And this is totally up to you. This is, if you understand what's going on, you don't have to do this. If variables mess you up, then I would suggest maybe changing them here. Now that I'm in a new triangle, this end right here is ultimately, maybe, potentially, sometimes different than the end that I was talking about over here. Does that make sense? So this is where I'm kind of viewing this as a different problem, a second problem inside the original, okay? So it might make sense for some of us to say, well, I'm going to call this M instead, and then I've got M's all the way through here, okay? For this problem, it doesn't make a whole lot of, it doesn't create too much issue, if any, because of the way this 30, 60, 90 triangle was overlapping, the 45, 45, 90. If this would have been 60 up here instead of 30, the variables, I think, get confusing. N is just the arbitrary letter that gets used a lot, but it doesn't matter what letter you use. All right. So when I look at this situation, would you guys agree that when I put this template on top of the blue triangle, that 8 radical 2 matches up to that? Then the brace that I'm looking for, which would be this distance, right? Put the blue triangle back on top of the picture over here. That's the purple distance. Does that match up to this 2N right here? And we just said N was what? Yeah, we just matched them up. N was 8 radical 2. So if I double that, I get 16 radical 2, correct? Okay. So in your homework, there was a part A. That's the answer to look for. Now, in part A, they go ahead and say, type it in, like round to 2 decimal places, something like that. But if I've got the exact answer, it's just as easy to type in a Desmos or my TI or whatever, and getting out, they could ask me round to the nearest, millionth. I could do that because I have the exact answer right there. That make sense? Okay. The next part of the question says, how much higher on the building does that second brace reach? Okay. So we want that distance right there. Okay. Do you know that distance? Throughout this picture, this process of pulling things apart, do you know if that distance there is 8 radical 2? Okay, so that's good. So you know that distance, 8 radical 2. Do you know, or maybe do you have the ability at least to find that distance? Would you guys agree that, kind of running out of colors here, that red distance right there is the same as that one? Now, we haven't spent time finding that one, so let's find it. Remember, in a 30, 60, 90, across from 60 degrees, just like down here, is your N radical 3 side, right? Remember, 8 radical 2, this blue triangle was N. So this distance here would be 8 radical 2 times radical 3. Does that make sense to everybody? So what's 8 radical 2 times 8 radical 3? 8 radical 6. Does that make sense? Okay. So let's say that, let's say Mr. Fay is 8 radical 2, whatever, tall. Drake is 8 radical 6, whatever, tall. Feet, inches, whatever we're talking about. And I ask you, how much taller is Drake than Mr. Fay? What would you do with those two numbers that I gave you? Subtract them. Okay? So that's essentially what they're asking for here. How much taller is this 8 radical 6 than the 8 radical 2? So to find that distance right there, you're going to subtract 8 radical 6 and 8 radical 2. And that is where we start talking about our algebra concepts. And this is so a lot of times like the end of course exam is they're gonna give you the ability. They're probably gonna give you nice numbers that you don't have to do that with, or they might do some rounding things or give you multiple choice questions. So a lot of times, if we're geared towards the end of course exam, working with radicals, working with simplifying things might not be a huge concern. It is a concern, but it's not like a paramount, top of the notch, biggest concern that I have for us. Okay. But remember, the end of course exam is just one hoop we gotta get through. Okay. My end result is for you to become competent math people, right? Become mathematicians. Be able to use this stuff in algebra 2. Be able to use this stuff college algebra, trig, stats, that kind of stuff. So in those other courses, you're gonna be asked, can you simplify this? Can you leave 8 radical 6 minus 8 radical 2 as a more concise value? Okay? And the number one answer is yes. And the number one answer is that result should end up being what? What do most people say this should equal? 8 radical what? I get a lot of 8 radical 4s. Okay? I get a lot of radical 4s as well, or 2. Okay? And here's my question. If that's a legitimate process, then shouldn't I be able to go to a calculator and type in 8 square root of 6 minus 8 square root of 2, get an answer, and see if that's the same answer as 8 square root of 4? And they're different, right? So does that tell me that the subtraction that I use to generate 8 radical 4 is not a legitimate way of doing that? Does that make sense? So let's talk about the rules that we've learned, hopefully last year, about radicals, and that you will spend more time in Algebra 2 talking about. Okay? Radical 6. Just, some of you might know this. Okay? Does anybody know what that decimal is? Okay, good. Let's say it's unknown. Unknown. Don't know what it is. Radical 2. Let's say that's unknown. Okay? But would you guys agree that radical 6 does not equal radical 2? Okay? So if they're unknowns, what do we usually let our unknowns be in algebra? Variables. Okay? So let's say that this radical 6, let's let that be x. Let's write this radical 2, and this is the reason I said, is radical 6 the same thing as radical 2? Radical 6 is different than radical 2, right? So I can't let radical 2 be x as well. Does that make sense to everybody? So what would you let it be? Let it be y. Okay? So if I've got 8x minus 8y's, from what you know about polynomial work, from what you know about like terms and all that kind of stuff, would you write that any different way? Would you ever simplify that and write it as x minus y, or I don't know, some option 0 or anything like that? Would you ever simplify that? Are those like terms? How do I identify like terms in algebra? They have to have the same exact variable and the same exact power for those variables, right? Are those the exact same variable? So I cannot combine them, right? Okay. So if I can't combine those, and we identified radical 6 and radical 2 as x and y respectively, that must mean that I cannot combine those. Does that make sense? Okay. In the whole grand scheme of things, if I have that 8x minus 8y, what we're looking at there is, 8x means you have x plus 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 x. I mean, there's 8 there. And then the y means minus y, 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 minus y. And if I ask, condense those into one simpler term, you can't do that, right? You get x's and y's. Okay, they're not like terms. They don't cancel each other out or anything like that. Same thing here. 8 radical 6 means you have radical 6 plus 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 radical 6 plus, I think you need one more, radical 6, right? My radical 2's means minus radical 2 minus radical 2. One, two, three, need one more, minus my radical 2. And the idea there is none of those cancel each other out or double with one another or anything like that. Does that make sense? The 6's and the 2's. So all I can write it as is 8 radical 6 minus 8 radical 2. That is actually already fully simplified. That would be the exact answer. Okay? And it's because essentially we can view radical 6 and radical 2 as variables, different variables, and then they're unlike terms. Okay? A lot of times we call them unlike radicands. Okay? Think about this, and this might make a comparison that allows us to justify that process maybe a little bit better. So let's see an example of where we could combine things. If I had, I'm going to use smaller numbers, like 3 radical 2 plus 4 radical 2. Okay? Well, using kind of the unknown idea, if I let that be x and I let that be x, we'd call this 3x plus 4x, wouldn't we? And you could call that 7x. But what would we let x be? We let x be radical 2, right? So it makes sense that those are going to add to give me 7 radical 2. Does that make sense? Or, remember, multiplication means repetitive addition. So I can write this as radical 2 plus radical 2 plus radical 2. Okay, so that's my 3 radical 2. And then radical 4 times radical 2 would be this. Radical 2 plus radical 2 plus radical 2 plus radical 2. How many radical 2's do you have in all? If I counted those, don't I have 7 of them? So that turns into 7 radical 2's. So that is a situation where I can combine radicals, and it's because of that idea that the radicands are the same here. They're like terms. So the general rule for adding radicals from algebra is if that number there and that number there are identical, you can add the numbers out front. Essentially, we call the 3 and the 4 coefficients of our radicals. We can add those, okay? Or maybe we call them the rational part of our radical here. So here's my question. Knowing that then, what is 3 radical 2 plus radical 8? Are the radicals there the same? No. So some people might initially say, can't add them. 3 radical 2 plus radical 8. That's the simplified version right there, because he just said that the radicands had to be the same, right? However, they have to be the same in simplified version. What's radical 8 simplified? Okay, so radical 8 turns into radical 4 times radical 2, right? But what's radical 4? 2. So we have 3 radical 2 plus this thing turns into 2 radical 2. Now are these radicals the same? So now I add the numbers out front. 5 radical 2. Okay? And the question is, so I always get people to ask, it's always, can I do this? Well, check. Check to see if that what you just did made sense. I go 3 square root of 2 and add to it radical 8. It gives me that decimal, right? Well, if I legitimately did correct algebra, and 5 radical 2 should be the same exact decimal. And that hopefully then proves to us that, yeah, the steps we went through worked, okay? I want you guys to use your technology. I don't know how many times, and I wish I could maybe set up like situations for us where you would experience this, but I don't know how many times when I was in a high school math class or a college math class on a test or a quiz, and a rule or property left my mind. And I totally forget, what am I supposed to do here? Or what am I allowed to do here? Is this algebra okay or not okay? And I would be able to get myself out of that problem or that issue by turning to my calculator and just doing something by hand and say, okay, if it looks like this to start off with, I do something by hand, it looks like this. Are those two things equal? By just plugging in the first one and what I came up with in my calculator, see if they evaluate to be the same. If they're the same, then yeah, that must have been the property I forgot. If they're different, nope, that property ain't what it needs to be. Does that kind of make sense? And you can save yourself a lot of maybe issues when something doesn't make sense by just trying something and see if you get a result that is equivalent to what you started with. Okay.